All right, boys and girls, welcome back to the drive-thru, sponsored by the deli. Hungry? Stop by the deli. Make yourself a sandwich with some pepper turkey and rare roast beef, provolone cheese, James, on ciabatta bread. We're doing 10-2. Sorry, that is not true. We are doing 1-2, measuring segments and angles. Some vocabulary that you will recognize are acute angles, obtuse angles, right angles, and straight angles. Some vocabulary that might be true, so you might want to pause the video and take this down if it matters to you. Remember, notes should be meaningful and necessary. So if you already know them, don't write it down. If you don't need to know it, don't write it down. Congruent, these are when two things have the same measure. So angles can be congruent, they have the same measure. Segments can be congruent. Okay, one way we can break up angles is turn them into degrees, minutes, and seconds. So, for example, we could write it as 71 degrees, 15 minutes, and 29 seconds. So, this is a way to break up degrees into little portions. There are 60 minutes in a degree, and there are 60 seconds in 1 minute. So that's probably the most confusing part of this section. There are some challenging problems that go along with this section as well, and with the remainder of this video we will just focus on doing some type of problems from the homework. Okay, find the measure of DBC. If ABC is a right angle, so we know that ABC is 90 degrees. Okay, and it's given to us that angle ABD is 67 degrees, 21 minutes, and 37 seconds. Well, while we're in class, Mr. Yulin is going to show you how to do this on your calculator. Okay, it's very easy to do this on your calculator, but if you don't have a calculator and you need to do it by hand, you should be able to do that. So you got to keep in mind, 90 degrees. Well, that's the same thing as 89 degrees, okay, and 60 minutes. That would be like saying that if we were measuring time, 2 minutes is the same thing as 1 minute and 60 seconds, okay? So we could also write that then as 89 degrees, 59 minutes, and 60 seconds. Okay, so you have to kind of think all of these things, this, and this, sorry, they all are the same thing as 90 degrees. If you can remember that, this problem isn't too difficult. So to find out what this angle is, we need to take 90 degrees, which we are going to write as 89 degrees, 59 minutes, and 60 seconds. And you need to subtract 67 degrees, 21 minutes, and 37 seconds. All right, so 37 from 60 is 23. Okay, 21 from 59 would be 38, and 89 minus 67 is 23 degrees. So if we add those up, it should give us to 90. Indeed, it does. That's how you would do this by hand. Make sure you stay tuned in class to find out how to do that in your normal scientific calculator. Okay, a second type of problem. Angle B is acute. Part A, what are the restrictions on angle B? So you could say that angle B must be bigger than 0. It cannot be bigger than or equal to 0. And it also has to be less than 90 degrees. It cannot be equal to 90 degrees, or else at that point it would turn into a right angle. So that is the answer to part A. For part B, well, we know that if we want to find the restrictions on x, we know that we can substitute 2x plus 14 in for angle B. So what this says is that 2x plus 14 has to be bigger than 0. So that's one of our... And it also has to be bigger, or sorry, less than 90. We just solved this equation twice, this inequality twice. So subtract 14. You get negative 14 is less than 2x. Divide each side by 2. So we know x has to be bigger than negative 7. Okay? Divide each side by 2. X has to be less than 38. So x has to be bigger than negative 7. It has to be less than 38. So we would write that like that, and that is the answer to question B. So that's maybe a new style of problem. The algebra itself isn't challenging, but maybe the type of problem is challenging. And this will be the most challenging type of problem from your homework, and these are the famous clock problems. Find the measure of the angle formed by the hands of a clock at 2:15. It's my first chance to use this famous acronym invented by Mr. Lothrop, WIDMAPOI, which obviously stands for when in doubt, make a picture of it. WIDMAPOI, okay? So we need to envision this scenario. We know that up at the top of a clock is a 12, and then a 1, and then over here is a 3, 4, 5. There's half of a clock. Unfortunately, you guys don't know how clocks works very well because you've had digital clocks your whole life. But the big hand is pointing at the 3. Where people will make mistakes is that they will say the little hand is pointing at the 5. But that's not true. Because as the clock moves, hopefully you understand that the hour hand moves with it. So the hour hand is going to be in between the 5 and the 6. Well, how far has it moved? Since we are 15 minutes through the hour, okay? We can say that the hour hand has moved 1/4 of the way between the 5 and the 6, okay? 1/4 of the way between the 5 and the 6. So now we have to think to ourselves, how many degrees are in a circle? So one circle is 360 degrees, okay? Well, then if there are 12 numbers on the circle, so one number will be 360 divided by 12, okay, which is 30 degrees. So each time, that is 30 degrees. 30 degrees. Okay, well, what about 1 minute? Oops, 1 minute. Well, that's going to be 360 divided by 60, so that's 6 degrees. All right, so we want to know the measure of that angle. Okay, well, between 3 and 4, 30 degrees has passed. Between 4 and 5, 30 degrees has passed. So this answer is going to be bigger than 60, but less than 90. Okay? Well, what we need to know is how many degrees is this little sliver here? This little sliver that we're going to add to our 60 that we've already calculated. Well, that sliver represents 1/4 of this 30-degree movement. Remember, this would also be 30 degrees. So 1/4 of 30 is half of 15, so that's 7.5 degrees. And so the answer to our question is 60 plus 7.5 67.5, and that's going to be 67.5 degrees, or you could write that as 67 degrees and 30 minutes. Good luck on your homework. Hope you enjoyed today's confessional. Boom!